So let's move on. So we have a lot of questions here. We have another question. So let us solve this on our own. Let us try. A ball is thrown vertically upwards with a velocity of 2 meters per second from a multi-story building. It is thrown vertically upwards. Yeah. The height of the point where the ball is thrown is 225 meters from the ground. How high will the ball rise, and how long will it be before it hits the ground? So we have G as 10 centimeters. Yeah. Let's go ahead. So what we'll do is we have so this is the diagram. So 25 meters. Wow, we have drawing wala here. Okay, we have this one here. Nice. So we have a 25-meter wala thingy, and then we have it'll go there, it'll come down. So what we want to understand is, so acceleration is 10 minus 10 meter per second. This is 25. This is 25. We know this. This let's yeah, assume it's y. They've assumed it as y. They've assumed it as y. So what we'll do is this is y naught. This is y. This will come back. So this b to a point b to a will be y minus y naught. This will be y naught. This will be y. So what we have to find out is how long. We'll have to find first. We'll have to find y minus y naught, and we'll have to find the time. So if you find this 2, right? So is thrown upwards with a velocity of 2 meter per second. So 2 meter per second is the velocity. So the distance. So the time we don't know. Do we know the so y minus y naught will be we do not know x, right? Okay, let's just have this. So y minus y naught will be x, that is x, right? So y naught is basically 25 meters. So this is y minus 25. Y minus 25 equals to x, right? And what is the speed? The velocity is thrown upwards with a velocity of 10 meter per second. So the velocity, it's not 10, it's 20. Shit, I'm a stupid person. I'm so sorry, I'm like so freaking distracted today. So yeah, it's 20 meter per second. So it goes up. So which formula do you think we should use from all of these three? I think this one will be appropriate. No, we don't need acceleration. This one, because we have displacement. We need to find. Sorry, we have the velocity. We just have to find displacement. So the velocity v square is this. So there is no acceleration here. There is no yeah, is thrown upwards vertically with this thing. So there was no acceleration, zero acceleration. So this will be 0. So v square equals to 2ax. Okay, that'll not be appropriate too. For all of these we need to find acceleration, which will be very tricky. So how do we do it? Okay, I don't know. Okay, let's once we've tried it, I mean, we'll know what are the gaps in our learning. So yeah, it's not a bad thing that we do not know. So let's erase. Oh, erasing is so easy. I thought it'll take like forever to erase. It was like took 2 minutes. Wow, it's amazing. So yeah, let's move ahead. Uh, we did not understand this. So.
Calculus.
Oh my god,
Answer by
not there,
definition.
not there.
A. Let us take the y-axis in the vertically upward direction with 0 at the ground, as shown in Fig. 3.13. Now wo is equal to plus 20 ms1. A is equal to g is equal to 10 ms2. V is equal to 0 ms1 if the ball rises to height y from the point of launch. Then using the equation 0.
So we are taking it in the y-axis because it's vertical. So that is why it's y. So in figure 3.31, you see that 1.3, you've seen that. So V naught is 20 meter per second. So V naught is 20 meter per second. That we know already. And V is 0 meter per second. Okay, yeah. V is basically 0. So it starts with 20 and ends with 0. That is where I was going wrong. I thought it was constant. I didn't think it was constant. I assumed it. I didn't even spend brain energy on that. So what they're telling is here the velocity will be 220 meters. Here it'll be 0. It's going up, right? So it'll be 0. So V naught will be 20 and V will be 0 and A will be 10 meter minus 10 meter per second because it's going up. But then still it is experiencing acceleration, downwards. So this is the acceleration, and here we don't have to know the time, so this is easy, right? This is easier with this equation, so we substitute in that equation and find the answer of A, which is 20 meter per second. Oh shawty, bonanza. Okay, then we have Go Shari, it's your birthday. I need to stop watching reels, man. We can solve this part of the problem in two ways. Note carefully the method used. So yeah, they are, calculate is showing us methods. Whoa, interesting, right? We can, if we learn more methods, we can like finish it in easy steps. So yeah, let's understand the methods then.
Fig. 3.13. First method. In the first method, we split the path in two parts, the upward motion, A to B, and
Okay,
the downward motion.
for B, how do we solve? Okay, for the B part, we for the first method we split it into two parts. This part and this part. So we know y1, y naught is 25. This part we'll have to find out. We'll have to find out x, and we know x, which is 20 meter per second. This is 20, so 20 plus 20, 25 will be 45. 45 is the whole length. So that is acceleration. So from acceleration in this formula we can find out time, right? From that formula, or we have already v naught and v this thing. So here the v naught is 0, and here here it's also 0. So that is again tricky. So regardless, it's minus meter per second square. Yeah. Okay, let's see what the NCRT is saying. And yeah, even if an object is going upwards, this is a very important thing I had to tell you guys. Even if an object is going upwards, even during this part, the retardation is 10 meter per second. The acceleration is minus 10. Why? Because even while going upwards, at each second, its velocity is decreasing. You get me? At each second, this second it's the highest, low, 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 lowest. So yeah, that's an idea. Yeah.
Integrating both sides. Fig. 3.13. First method. In the first method, we split the path in two parts, the upward motion, A to B, and the downward motion, B to C, and calculate the corresponding time taken t1 and t2. Since the velocity at B is 0, we have V is equal to V plus at 0 is equal to 2010 t.
Okay, so we take A to B, A to B, and B to C. So we take two paths, upward motion and downwards motion. So we can so since the velocity at B is 0, we have so the velocity at B is 0. So from that we understand that the time taken for this is 2 seconds. For this, y minus a is 2 seconds. Y minus y naught is 2 seconds. 1 second. We'll continue for the first method and the second method fully in the next part, and we'll also start relative velocity. We'll also finish the first and the second method, and we'll finish all of these examples and also reaction time, and then start relative velocity in the next part. So bye guys. Relative velocity is like this, only this one paragraph. Okay, these two paragraphs. So we have to understand more, then we have to ratify. So yeah, we'll talk to you later.